So many problems with evolution. Today, I'm here with biophysicist Dr. Cornelius Hunter, and we're going to be talking about two things that start with the letter V that refute evolution. So, welcome, Dr. Hunter. Thanks for being here.
Thank you for having me on your channel, Rebecca. And yes, I do want to show you guys two things that start with V that refute evolution: viruses and vision. So the first one, viruses. And, you might think that within evolutionary theory, viruses are not that big of a deal, right? I mean, the evolution of viruses is a sidebar. Well, no, that's actually not true. Within evolutionary theory, they are crucial. The reason is there are too many similarities between viruses and cellular life. So it's not just a different story. They must be, if evolution is true, they must be integrated. The evolution of viruses must be integrated, part of the story of evolution, part of the story of how cellular life evolved. So within evolutionary theory, the evolution of viruses is crucial. It must be explained. It is just absolutely required. You turn that around, if the scientific evidence does not indicate the evolution of viruses, if virus evolution is not contraindicated, then evolutionary theory has a monumental problem. Well, guess what? Yes, the scientific evidence contradicts the evolution of viruses at several levels. It would take hours and hours to explain it all, but I'm going to show you guys some examples and explain how the evolution of viruses is not indicated by the scientific evidence, and it's refuting evolution. So let me show you an example right off the bat here. This is an image of a cell, and a virus has inserted itself into the cell and hijacked the machinery, and it's created this thing called a VF. If you see that dark blob there toward the top of the cell, that VF stands for virus factory. So this virus has created this virus factory, and there are several newly minted viruses hanging around the edges of that virus factory. They're emerging, and they're being created. They're being polished off. And now this is a giant virus. This is the first of the giant viruses that was discovered. It's called Mimi virus, and so it's good for making these images because we can see it a lot better because it's so big. So there you have the virus factory and these newly minted viruses emerging from the virus factory that has been set up. Now, no, by the way, that was 8 hours after the cell was infected. Fast forward to 12 hours, you still see the virus factory there. A lot more viruses proliferating through the cell. So the cell is really getting close to, getting finished off here. And now zoom in on one of the viruses, and there is a Mimi virus zoomed in, and what a beautiful little machine that is. Look how symmetric it is and polished off, ready to go and infect more cells. So the evolution of this Mimi virus, there's no explanation for it. There's no sequence of mutations. What mutations happened? What was the sequence? How is this thing how did it evolve? There's no such thing. Zip. There's nothing to explain how this Mimi virus evolved. Now, it's much more complicated than the smaller typical viruses, but there's no scientific explanation for how one of the small viruses evolved. There's no scientific explanation, no step-by-step sequence of mutations, sequence of events for the evolution of any virus. It is eluded scientific investigation, and not for lack of trying. There is a lot of work being done on virus evolution.
Well, now, Dr. Hunter, immediately I know people are going to respond and say, well, just because we don't know something doesn't mean we won't figure it out later. So, this is not evidence against evolution because just not having an explanation, there's lots of things that we didn't have explanations for before, but we eventually found the explanation, and we'll do that for viruses.
Right. And so that's, a theory of protectionism. You cannot attack a theory. You cannot explain that a theory is failing because it can never fail. There's no problem is serious. They can't reckon with problems. Now, I'm going to remember I said it failed on several levels. So that's the first level. There's no plausible explanation for a single virus. Okay, that's the first level. However, it gets worse. So because evolutionists do not even have a plausible high-level cartoon of virus evolution. And it's not simple. Now, your point was, well, just because we can't. Well, there's things that we can. So the scientific evidence is showing us things that contradict the theory of evolution. I'll mention that here in just a couple of slides here. But the first point here is that I'm switching now from a detailed scientific explanation of how a virus evolved, step-by-step mutation, to high-level cartoon. So remember, viruses are much simpler than, typically, most viruses are much simpler than cellular life. And evolution has failed to explain the origin of cellular life. But you'd think, well, okay, let's start with a simple case. Let's explain, how did a simple tiny virus evolve that has a very small genome? No, even there it has failed. But let's go to the easier case now. Instead of a step-by-step scientific explanation, okay, we can't do that. How about at least a plausible high-level cartoon? What they call scenario. They use the word scenarios. Let's develop a scenario. Well, then this happened, then that happened. Even that fails. So here's a paper that says it is widely accepted that viruses are polyphyletic. I'll come back to that polyphyletic in a second. But a consensus scenario for their ultimate origin is still lacking. So a consensus scenario. This is high-level cartoon. Traditionally, three types of scenarios, three categories of scenarios for the origin of viruses have been considered. Now, within the scenarios, there's many different ideas. So there's actually a lot of ideas, of hypotheses for how viruses evolved, but they kind of fall into three broad categories they call scenarios. So there are two problems that start with P that we just saw. Polyphyletic and a primordial. So what is this polyphyletic? So remember, the key sub-hypothesis of evolutionary theory is common descent. You have to have common descent. Well, you don't have to have it, but it is very important. You want to have common descent. All of the species came from this LUCA, last universal common ancestor. All of the viruses came from this common virus ancestor. It didn't work. They had to divide viruses into different realms, and each realm has its own common ancestor. So you do not have overall universal common ancestry for viruses.
Now, why is that so important in evolution? My understanding is that it's because it's so hard and implausible to even get these things to come about once, that we need it to be only once, because otherwise it's just multiplying the problems exponentially. So is that the main reason that's driving that it has to be common ancestry?
I think you could say that's the main reason, but there's another important reason from the philosophy of science, which is explainability. So one of the big selling points that Darwin had, and evolutionists have promoted ever since Darwin, is it's the smoking gun. So, and in Darwin's day, it did kind of seem like, because there was such limited knowledge, it did kind of seem like, gee, yeah, that could be the smoking gun, because there were debates going on how to explain similarities between species. And there wasn't, there was two different sides. They didn't quite have the solution. And Darwin came out and said, hey, I got the solution. common descent. You guys are in camp A, you guys are in camp B. This is the idea that solves this, that resolves this problem. You guys no longer have to argue. Common descent explains us. It's the smoking gun. So philosophers of science talk about this idea of a smoking gun. You want to have this concept that just, solves complex problems in a one fell swoop. So you're looking for simplicity. That's the key to scientific theories, simplicity. F equals ma, just all of a sudden solves all these things. Universal law of gravity, all these things suddenly fall into place. Now we know why the planets are in ellipses and not circles. It comes out of these simple equations. F equals ma, universal law of gravity, inverse law. All of a sudden, everything works just fine with these simple little equations. So that's what common descent is. It's Darwin's equivalent of Newtonian physics. And so it's really important for simplicity. When you have to drop common descent and go to multiple ancestors, all of a sudden you're wondering, oh, why the theory then? Why should we think that evolution is true if you don't have common descent? Well, that was the whole thing. Is it with independent creation, you have multiple ancestors. God created all these things independently. It doesn't work. It's too complicated. Common descent solves everything. It explains why you have these similarities. That has failed over and over and over again with cellular life. Here we see it's failing with viruses. So yeah, your point, Rebekah, that things are just really complicated and really difficult to evolve. Well, let's minimize the times that they evolved. But it also talks to explainability and parsimony. So they use this word polyphyletic. Now I'm going to go back to that last slide. It is widely accepted that viruses are what? Not monophyletic. Monophyletic is universal common ancestry. Monophyletic. Now we dropped that. We had to drop it. And so when we dropped it, did we drop evolution? No. We just said, oh, well, I guess evolution, I guess viruses evolved from many different common ancestors. And as the years go by, the number of realms increases. The evolutionists have to keep on splitting the realms to have more and more and more realms. Right now, the committees are going through this process of more splitting. So there's going to be more. Each realm has its own common ancestor, and we're going to be in the dozens pretty soon. So we don't have monophyletic; we have polyphyletic. Now, the fact that evolutionists have kind of not skipped a beat and said, oh, well, I guess it's polyphyletic. Oh, that's the way it goes. That shows that common ancestry, this is a sidebar. I'm going off on a tangent for 1 second here. That shows that common ancestry is not core. Evolutionists can forfeit common ancestry despite what Mr. Nelson told you in 10th grade biology class, despite what all the textbooks say, common ancestry is not core. You can forfeit common ancestry and still be an evolutionist. No one's going to say, hey, what? You just said polyphyletic? You're not an evolutionist. We're not going to publish your papers. No one ever says that. So what is core to the theory if common ancestry isn't? And the answer is very obvious, actually, naturalism. If you hypothesize a non-naturalistic origins, then you're out. No more grant money, no more letters of reference, no more appointments, you're out. So that's the dividing line, naturalism. Okay, that's the sidebar. But here we have viruses violating common ancestry in a big way. Now, another P problem is primordial. So we said there were 3 camps or 3 categories of cartoons for virus evolution. One of them that they've had to seriously engage with and indulge, and many evolutionists believe this one is the right answer, is that viruses evolved first. Now, that never would have been acceptable years ago. Like, what are you talking about? Remember, viruses are parasitical. They have to have cellular life to succeed, to multiply. If a virus evolves and there's no cellular life, it's not going to do anything. It's just going to decay and go away. Well, because the scientific evidence is not indicative does not indicate virus evolution. They've had to do all kinds of mental gymnastics to try and figure this out. They lost common ancestry. It's now viewed as polyphyletic. There are many realms. Secondly, they've had to indulge and seriously consider this hypothesis that viruses actually predate cellular life. That's the way the arrangements, the similarities and differences work out, that, gee, the viruses must have come first. But that makes no sense. So viruses weren't really viruses at first. They were just kind of primordial ooze doing something. And then they turned into viruses after cellular life came around. So the complexity and the imagination is just going wild. It's not a simple theory at all. It's losing parsimony. And so this primordial, this word primordial, is one of the three categories of cartoons. Is viruses they date back to the primordial evolutionary times, the very first, even before cellular life came around. That is just indicative of the problem. Polyphyletic and primordial are two P words that are indicative of this problem, that it's not working. So it's not just, gee, they can't figure it out. It's the evidence is actually pointing in different directions. You don't have common descent. That's a positive finding of science that is contradicting evolutionary theory. It's positive in the sense that it's knowledge. It's not just ignorance. It's knowledge. We're gaining knowledge. We know that there are different realms. They cannot be monophyletic. So it's not working for evolutionary theory. Over the years, all three scenarios have been what? Revised, elaborated, temporarily abandoned, and revisited. So they're just kind of going around and around in circles. You can look through the literature. This was proposed way back, then it was rejected, then it came back, and so forth. To date, no clear explanation for the origins of viruses exists, period. End of story. It's not working. Summary: viruses do not fall into a common descent pattern, and they defy evolutionary explanation. So here is the common descent pattern. You've got these four different realms, virus realms. You want to have a single common ancestor. Years ago, this certainly would have been what evolutionists would have told you. If you looked at an old textbook or you went to a class back 50 years ago, that would have been the story. Oh, yes, of course, viruses have a common ancestor. Now what? They're polyphyletic. This is the story now. This isn't evolution. It doesn't make sense. Why do we need the theory of evolution if we're just continually creating more and more and more common ancestors? Summary: virus evolution is crucial. Without it, evolution cannot be explained. Evolution has no detailed step-by-step explanation for the origin of any single virus. Evolutionists do not even have broad cartoon-level scenarios describing virus evolution at a high level. There are many attempts, none of which work out very well, and this is not for lack of trying. Evolutionists admit virus evolution is a big unknown. Evolutionists believe viruses evolved not because of the science, but in spite of the science. Put another way, evolutionists believe viruses evolved because they believe evolution is true. That's the take home.
So what would you say the science shows? Like if you were going to say the science shows, would you say that viruses did not evolve? Like, could you make that strong of a statement?
Yes. That I would, to caveat, to forestall the obvious, what you want to say is today's science, because the game that's always played is, like you said earlier, we haven't figured that out yet. Oh, sure, of course. Anything can be figured out. Creationists can say this. No, we haven't figured it out yet. Okay, so what? We're talking about what the science is telling us. So yes, tomorrow, all kinds of things could come out. A new paper could be published that says, oh, we've solved virus evolution. So of course, the future, who knows what the future holds, right? Doris Day, que sera, sera. That's we're talking about science. And so we're talking about what science indicates, modern contemporary science. So I always like to say, today's science is contraindicative, contraindicates virus evolution. That you could say that's not controversial. There is no plausible cause for the evolution of viruses. So that's a quick overview of the evolution of viruses and how they refute evolutionary theory. Obviously, there's way more information on that. I did put out a longer video on this a couple weeks ago. And it is uncontroversial. It's obvious. I'm not like picking and choosing from the literature. So now I want to switch to the second V word here, vision. And I'll start off with a paper that came out a couple of weeks ago. Just take a real quick look at this paper and then step back and do a thought experiment. I want everybody to engage in this thought experiment. So here's the paper that came out a couple of weeks ago. Basically, the idea here is that when we see things, there's a whole lot of image processing going on in our brain. And one of the important steps in this image processing is simply awareness of what's important, what's not, what should be driving our attention. If you walk down the street or walking through the woods and something moves in your peripheral vision, you will automatically, involuntarily look. That's this process of, so you may think you're lost in thought and you're really kind of vulnerable, like you're not, using all your senses because you're lost in thought. You're not paying attention. You are actually, there's background processes working all the time doing stuff that you're not aware of. And one of them is this, what's important. And so you will all of a sudden, jerk out of your lost in thoughtness if something moves and you'll look. And so what this paper is talking about that. Now, this process of what I just described has always been thought to occur in the visual cortex. But this paper is claiming, well, we're also seeing it in the superior colloculus. We're seeing another parallel or separate process going on that is similar. It's doing kind of the similar thing. The issue here is that the superior colloculus is thought, if evolution is true, it is much older. It's much more primitive, right? The visual cortex is much newer, much more higher level. So let's read from the press release. For decades, it was thought that these computations were exclusive to the visual cortex. But we have shown that the superior colloculus, a much older structure in evolutionary terms, can also perform them autonomously. This means that the ability to analyze what we see and decide what deserves our attention is not a recent invention of the human brain, but a mechanism that appeared more than 500 million years ago. So this
500 million years ago?
Yes. So this this is before humans. This is before primates. This is before mammals. This is before all kinds of things. So this is the problem that crops up over and over again in evolutionary theory, which is early complexity. Early complexity, or you could say the evolution of structures before they are used, before they are needed. And this happens over and over again in evolutionary theory. Now, by the way, those quotes that I was just reading came from the final author of the paper. Skipping down in the press release, this ancient brain organization conserved for over 500 million years, 500 million years, became the foundation upon which the cortex later evolved its higher cognitive functions. Evolution did not replace these ancient systems, it built upon them. We still rely on the same basic hardware to decide where to look and what to pay attention to. So this problem of why would it do this? Why would we have these things? And we're spinning a story here now. Okay, well, evolution didn't replace these, it built upon them. Well, that's what you have to say if you're an evolutionist. but this isn't making sense from an evolutionary perspective. It's serendipity. It happened to evolve before it was needed. Now, let's move on to the paper itself.
But first, can I just stop you for a minute? Because I feel like this is really significant, as you're saying, because like you said, evolutionists are always trying to have these simple things happen early on. So they want to make it as if life was so simple and then it became more complex. But is this like is this what they're finding, that like this type of thing is needed in all of vision? Like every creature that has vision has this ability? Like, why are they saying it goes back that far? Are we going to get into that?
No, it's just that's because of the structure of the brain. When you look at different species, you look at the primates, you look at the mammals, you look at the amphibians, you look at the reptiles, you look at the birds. This visual cortex, this huge visual cortex that we have, is dwarfs what we find in lower species. So they have to say, oh, well, that evolved later. That wasn't there 500 million years ago, 500 million years ago. Whereas the superior colloculus, we do believe that was there because we find that it has a wider distribution across the species. It's all about evolutionary inferences from what we find in extant species.
Okay.
Where they decide what was there and what was not there. Yeah. It's just like when the DNA code was in the last universal common ancestor because it's in all species. So these are what you call phylogenetic inferences. And so they're happy to say that the superior colloculus was there, but the visual cortex was not. So here they're finding this high complexity that they thought was, a trademark of later evolution of higher species, but yet there it is in an older part of the brain, a more primitive part of the brain.
Okay.
Now, this is the journal paper itself, and it says that such a mechanism operates in the superior colloculus, a structure predating the neocortex. Again, that's an evolutionary phylogenetic inference. There's no scientific evidence that the superior colloculus predates the neocortex. That is an evolutionary gloss. So when you read papers, you have to understand how to read the literature. There's no scientific evidence for that. This is a non-scientific statement. It's not indicated by the science. It's an inference from evolutionary theory. That such a mechanism operates in the superior colloculus, a structure predating the neocortex, suggests it may represent an evolutionary conserved strategy for contextual visual processing. So I'm homing in here on the word strategy. Did you know that evolution has a strategy? It has strategies.
Oh yeah, there's strategies all over the place.
It's an agent.
Where is this? Who's making the strategies though? Because the strategy requires a mind. So
Exactly.
who's strategizing here?
Exactly. It's teleological. So the teleology runs all through not merely the press releases and the popular literature as it does, it also runs through the actual theory itself in the journal papers. And the teleology reveals the failure of the theory of evolution. They rely on it. They have to use it because the science contradicts the theory. Now, that's this paper that came out a couple of weeks ago. Kind of interesting, another failure of evolutionary theory. This is kind of constantly happening. I want to show you. Oops, I flipped the wrong thing. Sorry. Evolution as a strategy. There's the evolution as a strategy. Okay. So the teleology reveals the failure. I want to step back now to we're talking about vision here. What is vision ultimately? It's providing us with a conscious sensory perception. Our five senses are providing us with what you could think of as a movie, a motion picture, as they used to say. We're living in this motion picture. There's this Woody Allen movie where Woody Allen loves movies. He just loves movies. He's going to movies all the time. And he actually joins a movie. So it's kind of a supernatural way. He's in the movie theater. And he's so engrossed, and he joins the movie. He's in the movie. Well, that's what we are. We are in this movie. Conscious sensory perception. We are in this movie, and it's provided to us by our five senses. That's conscious sensory perception. So let's think about perception for a second. What is this perception? So I want everyone to go through this thought experiment with me here. We're going to do a very simple thought experiment. Imagine you had a microscope, a fantastic microscope, or some powerful instrument where you could look into your brain or somebody's brain, a patient's brain. Obviously, we have some instruments like that, but I mean a really good one where you can, look at the brain, you could zoom, pan, zoom in, zoom out, and just really see what's going on in the brain in a fantastic way. So, of course, you would see the left and right halves of the brain. That's, everyone's heard of the left, right side of the brain. You would see different regions of the brain that are kind of working together, and they work with each other as well, these different regions of the brain. You would also see, you could zoom in and you'd see the neurons. That is the basic brain cell. They're called neurons. And they have an axon. See this tail? They have tails that are sometimes quite long. And then they have these ends, and the ends join up. They contact, not physically contact, but they come real close to another neuron, and they communicate. Or they come real close to tissue, like a muscle or a gland or something. So they're communicating. So when I move my muscle, this is all by virtue of these electrical signals going through the nervous system and telling my muscles to move. So you would see that. You'd be able to see all that. Here's another image of a neuron with those axons, those arms sticking out. Really cool. So this is this thought experiment. You would also see, okay, here's a zooming in to where the end of the neuron comes in contact with something else. So the yellow is the end of one of those arms, and then the green is the other thing that it's coming real close to. When I say real close, again, they're not touching this gap. There's a gap between the yellow and the green that's called a cleft. This whole little system here is called a synapse. And we have like 100 trillion synapses in our brain. It's just some incredible number. I think that's roughly correct. I can't remember exactly. Just incredible number of synapses. Like in 1 cubic millimeter of our brain, there's like a billion synapses. So there's a lot of synapses. And I'll just explain real quickly how this works. So remember I said there's electrical signals. So you have electrical signals coming down this arm. It's called an axon. So electrical signals come down. When it reaches the end, the electrical signal reaches the end, you have these red little things called voltage-gated calcium channels. On the left-hand side, you see voltage-gated calcium channels. Calcium is a positively charged ion. When the electrical signal reaches the end, those open up by virtue of the voltage change. So the voltage-gated calcium channels open up. Calcium ions come streaming into the yellow, the axon. They will mate up with certain proteins. Proteins are not shown in this diagram. So you got proteins hanging around. Calcium binds up with these proteins, alters the proteins, and the proteins have the effect of taking these white bubbles and mating them to the membrane. So down at the bottom there in the yellow, one of them has merged with the membrane and opened up, and the contents are spilled out. What are the contents? So these white bubbles are called vesicles, and the contents of the vesicles are neurotransmitters. molecules that serve as neurotransmitters. They're going to transmit information. So the electrical signal comes down, calcium streams in, meets up with proteins. Proteins take those white circles, and merge them into the membrane, and they dump their neurotransmitters into what? The cleft. They drift across the cleft, and they made up with what? Neurotransmitter receptors, the red receptor machines in the post-synaptic tissue there. And that will influence, that sends a message to the postsynaptic side. Aha, something happened. We're getting a signal. And then all these things kind of recirculate for later use. So the neurotransmitters come back, more of these white bubbles are created. And then another electrical signal in the postsynaptic side might be generated as a consequence. There's a lot more complexity to this story. There could be other synapses nearby that are influencing this, all kinds of complexities. But that's the general story. Let me show you another one. This is another rendition here of a presynaptic and postsynaptic tissues. The presynaptic is the axon of the neuron, and you can see the cleft here, this kind of real thin area, and you can see in the lower right of the axon, there's this calcium 2+ that's been opened up. The membrane channel has, the voltage gated membrane channel has been opened up, and the calcium streaming in. It's causing the vesicles to merge, dumping the neurotransmitters into the gap. Does anyone think that this arose by random chance? This is a typical instance of what biology is like. This is what you learn when you go to biology class. Each class, each day, it's like another one of these revelations. It's just unbelievable complexity, coordination, interconnected complexity. The idea that this evolved is just silly. It's just a silly mythology.
That's obvious to me, and that's obvious to you. How do you think this is not obvious to so many people? Because so many people will say, yeah, hey, I don't see a problem with that. Why can't it evolve by step, slowly over time?
Because they have to have it for religious reasons. There's something else going on. There's cards that you have to see that they have. This isn't a scientific conclusion. The science is a handmaiden. The science is window dressing. It's being used. It's being manipulated to tell a story. The whole idea of evolutionary theory is use the science to gain credibility, to gain legitimacy, when in fact it has no legitimacy. It is driven by theology. And theologians, non-biblical theologians or non-biblical ideas and doctrines drove this. And that's why the history is so important to understanding evolution. History is not that, what Mr. Reed taught you in 9th grade, and I want to forget about it.
And when you say non-biblical, you're not talking about non-Christian, because a lot of these were Christian.
Yeah, they were Christians, but when I say Christians, I want to make it clear that Christians often will appeal to non-biblical doctrines because they're not very good Christians. So when I say Christian, they were Christians. That the majority of in modern era, the theory of evolution was mandated and promoted by Christians, and the table was set for Darwin in the centuries before Darwin by Christians. But I say non-biblical because I want to make it clear they were Christians, but the ideas are not Christian. So I want to make that distinction. So yes, you have a lot of Christians working on theological problems and following Epicurean from antiquity, the Epicurean idea that the world must have arisen by itself. So that became a very strong, powerful argument for many different theological reasons and advocated mostly by Christians. But I don't want to make that sound like it's biblical, because none of these ideas were biblical. So
And
Christian,
just to be clear for people who don't know you, who are watching, Dr. Hunter is very unique in that he is not a creationist and he's not actually even an intelligent design advocate. He's approaching this topic from a scientific viewpoint. But the reason we're bringing the religion into it is because evolution developed in a religious context. And so that's a lot of the background that he's studied. And I do want to take this opportunity to bring up your book, because even though he doesn't even want me to promote his books or anything, but these are like really worth reading. Darwin's God, Evolution and the Problem of Evil, really good. And Science's Blind Spot. These just really show you how there's such a religious base to the whole theory of evolution. So anyway.
thank you, Rebekah. I appreciate that. And the main takeaway there is, if you do not understand the theology and the history behind the idea, you're not going to understand theory of evolution. It's not simply, you can't just get a biology textbook and read the science. You can learn all the science in the world. You're not going to understand the theory of evolution, because the science is only one part. There's history, philosophy, and theology. So it's kind of the confluence of those four spheres that you have to understand all those. It's so crucial to understand all of them. So we're in this thought experiment. We got this instrument, this microscope, this fantastic instrument, and we're able to look at the patient's brain and zoom and pan and look in and look out. We see all these different cool things going on in the brain, like these synapses. Look what's going on here. Let me go to the next slide, because this one is actually an image of a synapse. And it doesn't, not everything shows up as well because it's real. And you can't just draw these nice little lines, but you can see next to that asterisk, just below the asterisk, some bubbles. And those are the vesicles. So that's the presynaptic side. The electrical signal is coming down and influencing those bubbles, because it opens up the calcium channels. Calcium comes streaming in, bonds with proteins. Proteins get these vesicles to merge with the membrane, releases the neurotransmitter. Transmitter drifts across the cleft, and then you see this dark. In the postsynaptic side, there's this dark, dense area. That's the buildup of something's going on as a consequence of these electrical signals. So you would see that with this cool instrument that you have. Isn't that cool? And you see all kinds of things like that. So we're back to this thought experiment now. Let's say that you had a patient, you've got the patient is awake, and you show it some pictures. Maybe you show it a blue sky. Okay, Jim, here's the blue sky. Take a look at this. And you're looking in the brain, and you're looking around, and you want to see, what can I see in the brain as he's looking at this blue sky? Can I see blue somewhere? Am I going to see blue? Would you see perception? He's perceiving things. He can tell you, yes, I see blue. Can you see perception? So he's looking at this blue sky. Would you see blue somewhere? Rebekah, you're saying, no, I don't think so.
No.
Where is the blue? I'm looking. They looked. I told this story to some, I blogged on this, and I have a lot of evolution readers back when I was writing this blog, and I blogged about this, that they looked for the blue. And they looked and looked, and they couldn't see it. And the evolutionists laughed at me. They made fun of me. They ridiculed me. What a fool. What an idiot. You don't know what's going on. Only a fool, only an idiot would think that they're looking for blue, that they're trying to see blue and they couldn't find it. Well, that's exactly the point. That's the point of the thought experiment. Only an idiot. We know intuitively, we know for sure that you're not going to see blue when you're using your instrument and you're looking into the brain. We know that, don't we? So did Gottfried Leibniz 300 plus years ago. One is obliged to admit that perception is inexplicable on mechanical principles. One could conceive the brain enlarged so one could go into it, like a windmill. Supposing this, one should, when visiting within the brain, find only parts pushing on one another and never anything by which to explain perception. So this is exactly what Leibniz was saying. You're not going to see, you're not going to sense, you're not going to perceive perception. Perception is not something we can measure. You can go into there, and he's using these old terms, windmills and stuff, but he's saying you're only going to see parts moving around. You're going to see things. You're not going to see the perception itself. You will see indicators of it. Like every time he sees blue, some certain voltages go here and there. Certain synapses fire off. But don't confuse that with perception itself. This is a key fundamental issue that evolutionists sometimes miss.
But what's the problem for evolution there? Because, they would say, well, yeah, we don't see that, but we don't need to see that for evolution.
We'll get to that. And just good question, because I'm getting right there. But first, I want to say that these quotes from Leibniz come courtesy of philosophy professor Dwight Goodyear's site. So thank you, Professor Goodyear. I will come back to Professor Goodyear in just 1 second. But getting back to Leibniz, looking at a patient's brain is profoundly different than the patient perceiving blue. I want to pound that home. I think we got that, right? You can see maybe antecedents. You can see some things happening every time he sees blue. Maybe you see certain synapses firing off. That's profoundly different than the perception that the patient is having. And evolutionists know that as well as anyone. Fundamentally different things, right? Common sense indicates perception is what? Non-material or non-mechanical, as Leibniz put it. Now, what about the science? So let's look at this. How does vision actually work? So light enters the eye, right? We all know light enters the eye, okay? We have the retina in the back of the eyeball. It takes that light, and what does it do to it? It transforms it, translates it into what? Electricity. So the optic nerve, it's going from the retina to the brain. It's about 1 million neurons. We just talked about these nerve cells and their axons. There's 1 million of these in the optic nerve. So think of it as a wire wrap. They're carrying electrical signals. It's electricity. It's not optics. There's no image. Sometimes you'll see a textbook showing the image. There's the brain, there's the human with his eyeball, and there's an image going into the eyeball, and then there's an image being projected into the brain. No, it doesn't work like that. You have now lost the image. There is no more optics. Optics is done. Post retina, there's no optics. There's no optical train like we have in our optical instruments. That's the way we do it. We have optical trains. No, this is converted to electricity. And we have those, we digitize optics with a CCD, and we transform it into electricity. We do that too. And so that's what's happening in our brain. No more optics. It's electricity. And the electricity then what goes into the brain? And then you have electrochemical gradients and dynamics going on as a result in the brain. Okay, what's the next step? Perception. The patient sees something that we do not see. There is something happening here that we cannot model mechanically. Perception is happening. Today, modern science indicates perception is non-material. So common sense told us that perception is non-material. Science is indicating that. We're back to like that virus thing we looked at. What is the science indicating? It's indicating viruses did not evolve. it is not, the scientific evidence does not support the theory that viruses evolved. Here, the scientific evidence does not support a mechanical or material version model of perception. It's indicating that perception is non-material. There is no, put it another way, there's no scientific evidence that perception is material. This is exactly what Leibniz said 300 plus years ago. Was he a genius? Yes, he was a genius, but it didn't take a genius. Because as I said a few minutes ago, as we talked about, it's common sense. So it's not, the science is not coming up with something revolutionary, it's confirming what we already knew. Okay, now, Rebekah, you asked, well, what does this have to do with evolution? Evolution requires material causes and effects. Evolution is working in the material world. It's an exclusively mechanistic material theory. God is not in there doing things. God is distanced. He's safely off in a distant Mount Olympus meditating. He's not in here doing stuff. The world is rumbling along on its own. So it is a strictly mechanical material theory. Don't confuse that with atheism. It's not atheism, it's theism. That's a sidebar. My point here is evolution, the theory of evolution, requires strictly material causes and effects, or you could say mechanical causes and effects.
Well, could you say that there is the material thing? We know that signal is going, from the eye to through the brain. And so there's an electrical signal there. That's the material cause. And even though we don't understand how that turns into perception, there is some material cause. There's some material thing happening there.
For sure. And that's what a lot of thinkers or dorm room thinkers get caught up on is, oh, well, but there's a material aspect to it. It's really just material. No, there's no question. As I said before, like when he's seeing blue, it might be that you can see certain synapses firing off consistently. So yeah, there is a material aspect to it. No question. This isn't all just immaterial simulation we're living in. For sure, there's a material side to it. But as I said a minute ago, don't confuse that with the perception part that is non-material. So we got to keep that straight. The perception is non-material. Evolution and the perception is crucial. We're living in this every second of every waking moment for every human. This isn't exactly obscure scientific evidence that you have to have a Ph.D. in to figure out. We are all exposed to this all the time. We are utterly without excuse because it is a mountain of evidence that everyone has access to all the time. And that's why it's so intuitive to us when we are objective and we're free of the theological mandates and we're free of the deception that evolution is. We are free to realize, oh, yeah, there's something more going on here. There's another world. There's something going on. That's obvious. It's obvious to us from a common sense perspective. Science is also telling us this, and it's been known for centuries. This is not something that's clever or hard to know about. Evolution requires material causes and effects. Perception isn't. Okay? Perception isn't material, isn't mechanical. It doesn't fit. It doesn't work. It's not a sidebar. It's not, well, okay, so evolution doesn't need perception. No, perception is crucial. It's all the time, every waking moment.
Well, are you saying this cannot, there's no possibility that perception could somehow be material.
Great
Like,
question.
Mhm.
Great question. And I'm glad you asked that. I'm making a very clear, I'm hoping that I'm making a very clear point that it fails that perception is not material according to today's science. Yeah, you'll always get the plea, the explanation. Oh, well, we haven't figured that out yet. Oh, okay, well, I think that pencils can float. I just haven't figured it out yet. Anybody can say anything they want and say, well, I just haven't figured it out yet. I'm going by reality. I'm going by what we actually know. So I always like to preface that modern science, today's modern science, indicates perception is not material. Evolution requires causes and effects to be material. This falsifies evolutionary theory.
Now, this is the kind of thing
According to today's science.
I have been making this argument to people about like origin of life and stuff like that. Like, if you want to be scientific in your thinking today, then you should believe that life did not come about by natural processes, because all of our scientific observations show that that is not, it can't happen, right? That's what our scientific observations are showing. But then people will say, but you're not understanding the scientific method. The scientific method is that we need to continue to test. And so if we don't understand perception, we just need to test it more. We just need more tests. And that's, that's what it is to think scientifically and to be scientific about your observations.
Right. And so these rebuttals and the discourse with evolutionists will always go philosophical and theological. They have to appeal. These are arguments designed to protect the theory from science. So when you come, they're using the science, they're manipulating the science to make it sound like the theory is scientific when it isn't. When you confront them with the science, they will always go into protectionism mode. And there's all kinds of philosophical and theological arguments of, oh, you don't understand the science, and that's got the gaps, and there's intellectual necessity. We have to have this in order to proceed, et cetera, et cetera, et cetera. So you get into all these philosophical, maneuvers and tangents and canards. Yeah, I'm a methodological naturalist myself. I do science by naturalism, of course. That doesn't mean that I'm going to confuse naturalism with the truth in all cases. Every phenomena ever observed can always reveal the truth using naturalism. That's a different position than I use naturalism in my science. If I'm going to build a bridge, I'm going to use naturalism. Okay, that's different than the truth claim that all of existence is entirely naturalistic. Those are very different claims, right? I can build bridges with naturalism. That's it. So yeah, you'll always get these philosophical theological rebuttals because they cannot handle the science. They can't sustain a scientific critique. So all of this falsifies evolutionary theory. Evolution cannot be true according to today's science. Again, I put that in there, according to today's science. Yeah, all this could change tomorrow. So what's wrong with this? I've just made this argument. What's wrong with this argument? Let's go back to Professor Goodyear and see what he has to say about this. Again, quoting from his site, he says the quiet part out loud. Quote, "Do we really want to accept a theory so inconsistent with the prevailing naturalism and materialism of the sciences?" You see, that's what it's about. It's being driven. That is an a priori assumption, an a priori axiom.
Wait, what is he talking about? What theory is he talking about?
Leibniz's theory, the idea that perception is non-material.
Okay, the idea that
He's
perception is
addressing
non-material, and
Leibniz.
now he's saying, should we accept that because it's inconsistent with materialism?
Do you really want to go there?
Hmm.
Yeah, Leibniz said that. And guess what? It's still relevant today. 3 centuries later, we still have the exact same problem. No progress has been made aside from a whole bunch of PhD theses, and the paper mill has been continuing for professors, philosophy professors. But we have, and I mean, a lot of thought experiments have been played and a lot of interesting ideas. I'm not saying it's totally worthless, but there's no solution. And so what should we think about that? I mean, if ever there was, how long do you allow a theory to be assumed to be true when it's failing over and over and over again? And so he's confronting that reality, saying that all the cards appear to be against us. But do we really want to go there? Because that is so inconsistent with the prevailing naturalism and materialism of the sciences. That's what's driving the thinking here, which is, of course, goes back to the theology at the foundation of evolution. We have to have a strictly naturalistic description of the world for theological reasons. Which raises the question, why are naturalism and materialism so important? That's what I just said. It gets back to the theology. It's all theological. This is all religious. Because naturalism and materialism do not come from the science. Naturalism and materialism are not empirical findings, period, end of story. Naturalism and materialism have no empirical standing. When I say, obviously, I'm talking about this enforcement of naturalism and materialism to describe all of reality.
Now, yeah, I want to clarify that for people, because there are some people who will say, like, well, look at all the scientific developments that have happened based on us using and believing in methodological naturalism.
Right.
And and they would give that as their reason for being committed to naturalism.
Yeah,
So
that's a totally unfounded leap that they're making. So that's why I said a few minutes ago, I can build bridges with naturalism, and I'm a methodological naturalist. That's what I do. I do my science by naturalism. I'm a firm believer in naturalism. I like Francis Bacon. Now, let's use naturalism. But Bacon was also smart enough to realize it doesn't have completeness and realism. You cannot have completeness and realism and methodological naturalism. You can have any two of those three. You cannot have all three. Maybe we should do a separate video on this, but you cannot have all three of those without some other truth. Like, I know that God would not create this world, therefore it must be strictly naturalistic. I know that God is separate, therefore this world must be strictly naturalistic. Aha, okay, if that's true, then yes, you can have methodological naturalism and completeness and realism. You cannot have all three without some sort of other truth that you're bringing to the table. We call those truths metaphysical, before the science or on top of the science. They are constraints constraining the science. Those are metaphysics. They do not come from experiments. They do not come from science. They are not scientific. Usually they are brute theological claims. So,
and for people who are not clear on this, because I feel like you're very deep into the philosophy and a lot of people may not even understand what you're saying here. So let me just say it simply, and then you can tell me if I'm saying something wrong. But so you're saying, look, we use methodological naturalism in science when you're doing something that is, like you said, building a bridge or doing scientific experiments. You're going to assume that there's not going to be a divine event that intercedes, and you have an expectation that things are going to proceed according to like a natural, like observable ways that we see happening in the world, right?
yep.
But you're saying to the leap that you're not making is you're not making the leap that says everything in reality can be explained in this same way.
Right. Exactly.
Okay.
I
So,
just built 10 bridges successfully, and they worked great. And with each one, I did a little bit better, and they got better and more effective. And my physics worked really well. And my naturalistic assumptions and my equations worked really well. Therefore, consciousness is mechanical. What? You just made this huge, unfounded leap. How did you get from A to B? That makes no sense at all. You're doing a great job with bridges, and so therefore everything in the universe is mechanical and material, and naturalistic laws explain everything with realism. No, that is a completely unfounded leap. There's no justification for that. You have to have some other assumption that you're hiding.
and
You're
you're saying that unfounded leap is what keeps evolution alive, because as our observations, we have so many scientific observations that contradict evolution, that it's actually this metaphysical leap to a necessity to explain everything by natural processes that keeps evolution alive and well in people's minds and in media and everything.
Yep, exactly. Although I would add one thing, not merely keeping it alive, but created it in the first place. It was the mandate. There was a theological mandate for Epicureanism, and in a very similar way, theological mandate for evolution. The only difference is the theology became more elaborate. Modern times, in the last 500 years, Christians mostly have elaborated much more so on the theology compared to the Epicureans. Things get more elaborate as we go through time, including the theology, right? It's not just calculus that we added and algebra that we added to the Greek geometry. We also added more elaborate theology. So, but it's conceptually the same thing. Yeah, you have theology driving and mandating evolutionary theory, and then, as you say, sustaining evolutionary theory.
Now, is this the end of your presentation? Because we have a lot of questions and comments from the audience that I'd like to take if you're done. But if you're not done, then I still want you to finish.
I'm not done. I'm getting close to being
Okay.
done. I'm going to read some quotes from some philosophers about consciousness so that we can kind of see what's going on. And then, so it's like half a dozen more slides. So these are theological mandates, as we've talked about. Indeed, mechanistic theories of perception and consciousness have what? Failed badly. They've failed hard. Here's a paper. Here's a popular article by Robert Kuhn about he's really interested in the problem of consciousness and perception, and he's interviewed hundreds of philosophers and scientists about this problem of consciousness. And he has written a journal paper recently and this follow-up article here. Consciousness is the ultimate question of existence. Nothing is more essential than our experience, yet we have no consensus and perhaps no clue about what it actually is. Okay, this is 2025. This is a month ago. He's admitting that this isn't really working. This is from his journal paper. Philosopher David Chalmers called humans motion picture-like perception. This is this movie that we're in. David Chalmers called this the hard problem. Okay, so what did Chalmers say? I see colors, reds, greens, blues, and they feel a certain way to me. I see a red rose, I hear a clarinet, I smell mothballs. All of these feel a certain way. You must experience them to know what they are like. You could provide a perfect, complete map of my brain down to the elementary particles What's going on when I see, hear, smell? But if you haven't seen, heard, smelled, that brain map is not going to tell me about the quality of seeing red, hearing a clarinet, smelling mothballs. You must experience it. Everyone knew that consciousness was a hard problem way before me. My colleagues, Nagel, Bloch, Broad, almost 100 years ago, Thomas Huxley back in the 19th century, even Leibniz and Descartes, they all knew that this was a hard problem. This does not mean this is quoting from the paper from Robert Kuhn. This does not mean, of course, that Chalmers is making a case for substance dualism. This is where you have a non-physical, a soul or something, some sort of a soul that's experiencing this perception. This does not mean, of course, that Chalmers is making a case for substance dualism. Some non-physical stuff like religions, immortal souls, and stuff like that. Chalmers is postulating a naturalistic dualism, where perhaps information is the connective, because while information is not material, it is embedded in the physical world. Again, we're back to the mandate, the metaphysical constraint. You cannot go there. What Goodyear, philosophy professor Goodyear said a few slides back, you cannot go there. That's a restriction. Has nothing to do with science, has nothing to do with logic. It's a metaphysical constraint. Now, here's some quotes from some philosophers I'll finish up with that are admitting, these philosophers are admitting, yeah, this isn't working. Matter is just the wrong kind of thing to give birth to consciousness. You might as well assert without further explanation that numbers emerge from biscuits or ethics from rhubarb. Jerry Fodor, we don't know, even to a first glimmer, how a brain or anything else that is physical could manage to be a locus of conscious experience. This is surely among the ultimate metaphysical mysteries. Don't bet on anybody ever solving it. Stuart Sutherland, consciousness is a fascinating but elusive phenomenon. It is impossible to specify what it is, what it does, and why it evolved. Nothing worth reading has ever been written on it. And physics, and I'll finish up with religion drives science and it matters. It's all religious. This is all theological. The viruses and the vision refute evolutionary theory. From an objective scientific perspective, today's science, objectively interpreted, if somebody dropped in from Mars and didn't have theology driving, it would be just totally obvious. Just like, no brainer, just hands down, slam dunk. Yeah, this theory doesn't work. I'm not against evolution. If evolutionary theory turned out to be true, if a paper was written tomorrow, all these problems were solved, that would be very interesting to me. I wouldn't have a problem with it, some theological, religious, metaphysical problem. I'm fine. I kind of laugh at it. I mean, it really doesn't make a difference to me. Okay, it doesn't float my boat. None of this really matters. It's kind of a joke. All these people are arguing so vociferously about this. So what? So what? I mean, okay, evolution is true. If God used evolution to create the world, I'm good with that. Okay, that's above my pay grade. I don't have a problem with that. If that's what God wants to do, he did it. I'm not saying it wouldn't be interesting. It would be provocative. It would be really, really very, very interesting to understand that. I'm not saying it's trivial, but it's not a metaphysical driver for me. Okay, so what? The problem is, what I am concerned about, and I am dug into, is the abuse of science. And I'm very concerned about the abuse of science. Science is abused. And it's a problem, in my view, that needs to be addressed, and people need to understand what's going on.
Well, and I think that's what makes you different than a lot of people who do this, including me, because, this was one of the questions I needed to get answered related to faith. Is evolution true, or is creation true? Because to me, I had a idea about, this is not the way God would do it, right? But you're coming at it with you're just strictly looking at the science, and what got you into it was the claim, right?
Yeah.
That evolutionists are making that it's true. And so for you, you weren't even considering origins as related to your faith.
Exactly.
So
Because it's
yeah,
such a heroic claim. It has to fascinate you when someone is staking their career and their reputation on this. It has to. Well, wow, that's a really heroic claim. I mean, I didn't realize it was a fact. Let's have a look at that. I mean, I remember Professor, Mr. Reed in my 10th grade biology class, telling me that it was true, but I never really thought much about it. And now here I'm seeing this as the consensus position of all leading, all biologists around, in academia, vociferously holding to this. There must be something really powerful. It's not exactly obvious. It's kind of, non-intuitive that, the world arose by chance. Okay, that's interesting. Let's have a look at that. And then you dig into it and you realize, well, wait a minute, this isn't working. The science doesn't support this. And then you get the killer arguments. And you kind of dig in. It's a little confusing. It's, oh, wait a minute. This is what they're talking about.
yeah. Okay, so I'm bringing up the comments now. So we have one from Howard. There is supposed to be common descent of all life, not all viruses. Snakes are polyphyletic, for example.
So snakes are polyphyletic only if you zoom in on the different snakes, but they all snakes would be monophyletic with all other life going back to the last universal common ancestor. So ultimately, all cellular life is believed, insisted upon to be monophyletic. Now, there are a few papers that have come out and have disputed this and said, gee, maybe life is not monophyletic because the evidence, because the universal common ancestor has failed so badly. So some evolutionists have had to admit and consider the possibility that life is not monophyletic. So it's not core to the theory. That's true. I agree with you on that. It's not core to the theory. But for when you say not all viruses, certainly viruses would have been predicted to be monophyletic before we knew the details of viruses. That was the hope. Evolutionists take no pride in the fact that they've had to continually split up the realms into more and more realms. They didn't want to do that. So it's not this is a problem with evolutionists is when you have massive failures in the theory, it is very quickly incorporated and they don't lose a step, and they all of a sudden switch from opposing something to, oh, well, that's us. Yeah, that's evolution, of course. So we need to reckon realistically with the actual failures of the theory, and that when you lose common descent, that's a failure of the theory.
Yep. And that just shows how flexible it is, that it can really accommodate anything and has accommodated many things that were not expected. So
yeah, so there's this concept of what's core and not core. And so it's very flexible in the non-core ideas, but not flexible in what's core, and that is naturalism.
And Andrew says nature is often not parsimonious. You start off with the simplest ideas to test, and often they become more complex as new data emerges.
Yes, that's true. And as a consequence, you drop theories that assumed things and theories that are no longer working. So you cannot sustain a theory that consistently fails.
And then a follow on, he says, I mean, viruses don't tend to leave fossils, so that makes things more difficult.
Yeah, granted that there's still a lot of evidence that we have from viruses that our evolutionists are grappling with. They don't fit evolutionary theory.
And also, Andrew, does having fossils actually show us the evolution? Because we find fossils and we find fossils of complex organisms with no predecessor. And so how is that helping us explain things? We have all these fully formed organisms. So I don't really know how finding fossils of viruses would help.
From an evolutionary perspective, I would say that fossils have helped us tremendously, so that because they give us more evidence about the world and about biology, and they show us that evolution didn't work. But
How
from an
so? Can you tell us more of your perspective on that? How do they show us that evolution didn't work?
Exactly what you just said. It's
Okay.
just this unbelievable complexity, as though planted there, as Richard Dawkins admitted. So the trilobites and the trilobite eyes are just, it just makes no sense. They're not in the right order. They don't go from simple to complex. You have complexity preceding simplicity often. You have incredible early complexity, and they just don't follow the evolutionary expectations. Yes, you can filter and pick out a sequence, and which has been done many times in many textbooks, and show a what looks to be an evolutionary sequence. Aha, there you go. But that's it's not a scientific objective rendition of the evidence. It's a theory laden perspective, where you pick out it's confirmation testing. You find the evidences that fit your theory, and you put that in the textbook.
Well, that brings me, I want to ask my question, because someone came on and recently challenged me about the overall ordering of the fossil record and said nothing but evolution can explain this, because, even though there might be problems with a sudden appearance of certain forms, but in general, we see, simple, like you see single-celled organisms, then you see multicellular organisms, then you see you
Yep.
know, progress that
Fish,
looks like, yeah, so
reptiles, amphibians, reptiles, mammals, birds. There is a general order, and it's non-random. There's a trend. That is a claim. Mark Ridley makes that in his evolution textbook as an evidence for evolution, in his chapter on evidence for evolution. That is something. Jerry Cohen has made that argument in his book, Why Evolution is True. You do have this general trend. It's non-random. All this comes up from the principle of plenitude. God wouldn't do it that way. So whenever you hear what you started off with there, Rebekah, was only evolution. Nothing but evolution explains this. Whenever you hear that, you're not dealing with science, because science doesn't make those sorts of claims. A scientist cannot say nothing but my theory, because that presumes not omniscience, a knowledge of all theories. And scientists don't have knowledge of all possibilities. They don't have knowledge of all theories. And so they don't make claims like, well, nothing but my theory explains this. That's a metaphysical claim or theological claim. And you get that a lot from evolutionists. A scientist would say something like, my theory predicted X and we found X. That's pretty good. Yeah, that is pretty good. Good job. That doesn't mean your theory is true, by the way. Do you understand that? Because that would be the fallacy of affirming the consequent. So you don't want to make that mistake. In fact, false theories have all kinds of positive confirmed predictions. My video is
I know you're
flickering.
starting to have a camera problem. Do you want me to turn off the camera for a sec or something, or
I might switch to my other camera.
okay?
Let me see if I
And
can do that.
so, but in regard, do you think the overall ordering of the fossil record is like support for evolution? Do you think it works? Like, I mean, and one problem with it is that we found the fossil record before the theory was developed. So they can make the story based on what they found. But do you think in general the order proceeds according to, like, a development, a slow development of life over time to
Yeah,
diversification?
when I read Genesis, I did see an order. First there was the teeming things in the ocean. the little things in the ocean, and then there was the land things, and then there was, man came last. I mean, it's kind of funny that, there was an order in Genesis. So a creationist could make the exact same claim.
And people are going to get confused because you do keep bringing up the Bible, but you say you're not a creationist. So can you kind of explain for people why you're not a creationist, even though you do believe the Bible?
Well, I can go there, but I want to finish off this problem here. This claim that the fossils have this general trend, and only evolution explains that. And you asked me, is that support for evolution? Does that? What do you say about that? I mean, is that an evidence for evolution? Yes, that's a confirmed prediction or retrodiction, whatever you want to call it. But yeah, that's evidence for evolution. There's tons of evidence for evolution. Every similarity you find between any species is right off the bat evidence for evolution, because that's one of the predictions. Now, when you look at the details of those similarities, they end up having problems and contradictions. But there's all kinds of evidences you can point to that would say, yeah, you've got evidence for evolution. You could say the same thing about the flat Earth theory. And that's why when I bring up creationism, I'm just bringing up there's all kinds of other theories that make positive, confirmed predictions. So confirmed predictions are not worth a whole lot by themselves. You have to look at a much deeper, broader look at a theory and what it says and all of its predictions and so forth. Science is very good at falsifying ideas. It's not very good at verifying or confirming or finding truth. That's one of the things about science. When you have a false prediction, that's not a good thing. When you have a lot of false predictions, that's a really bad thing. And you get to a point where it's like, yeah, this is a false idea. We've pretty much, dropped this idea of bloodletting or, whatever crazy ideas. Most scientific theories have failed. The vast majority of scientific ideas and models and hypotheses have failed. That's the nature of science. If you want to find a theory that's true, if you want to determine that a theory is true, that's hard to do in science. It's just by the nature of science. It's hard to confirm a theory. There's one backdoor kind of cheating way to do that. If you want to prove your theory and say that it's true, how do you think you might be able to do that? Set up a straw man, a false dichotomy, where it's either my theory or this other idea, and I'm going to falsify the other idea. Remember, science is good at falsifying things, so I'm going to falsify the other guy, and that will bring me to the conclusion that my thing is true. So you get into this dichotomy. It's evolution or creationism, and I'm going to falsify creationism. That's the whole project, the Epicurean project that has carried forth. And then you've got all the elaboration on all the different theologies. So this idea that the fossil records are non-random, that comes right out of the principle of plenitude, and how any non-random trends, God wouldn't have done it that way. And so therefore, creationism must be false, and therefore what? Evolution must be true. So that's the way these mental gymnastics tend to go. It's not a scientific argument. When I say scientific, what I mean is, oh, I have a prediction. It was confirmed. That helps my theory. Yeah, it does help your theory, but not very much, especially when you've got a lot of problems. Yes, the fossil record shows this trend. It also shows things. It also shows early complexity that defies evolution. It also shows things that appear planted there, as Richard Dawkins and you pointed out a minute ago. So we need to look at the preponderance of evidence and not just pick things out with confirmation testing. But what it really gets down to is this theological argument of, oh, it's not it falsifies the other guy, and so that's where we've totally departed from science altogether, and that's what this project is all about.
Okay. Now, this comment from Laserfam says the evolutionists have no detailed step-by-step explanation for the origin of any single virus. Therefore, evolutionary theory is wrong. That doesn't follow.
Well, yeah. So this is the question. Failures of a theory have to be judged as to how important they are. And so when you have a minor little failure, it's like, well, yeah, we can accommodate that. The problems that we have with the evolution of viruses are significant, and they are many. It happens at many levels. And I only covered a few of them in the talk. There's many more problems, but this problem that there's nothing even close to a step-by-step explanation for the origin of a single virus, nothing even close to that, is a problem. That's a significant problem. Now, does that alone falsify evolutionary theory? No. But you look at that with all the other problems, and you clearly have a problem that modern science, today's science, does not indicate. The preponderance of evidence from today's science does not indicate that viruses evolved. It's just that is a very clear outcome of the science. And the fact that you have journal paper after journal paper after journal paper talking about viruses must have evolved doesn't change that. Evolutionists will never admit that there's this problem. They admit that there's this problem. They'll never admit that it portends a problem with the overall theory that, gee, maybe viruses didn't actually evolve. You see, I'm in a position where I can accept the result that viruses evolved, but I can also accept the result that viruses didn't evolve. To me, I really don't care. It doesn't float my boat. Either one can be true. And so I'm free to look at the evidence and realize this ain't going anywhere. This ain't working. And not for lack of trying. I mean, paper after paper after paper, all they're finding are these problems and the lack of successes. I mean, if you can't accept what's really plainly obvious, and if you're always going to have the protectionist move of, oh, but yeah, you've got these problems, but that doesn't mean the whole theory is wrong. Okay, so it's protectionism, layer and layer and layer of protectionism, instead of acknowledging this is the way it's going. This is what today's science is indicating. Does it prove anything beyond a shadow of a doubt? No, things could change tomorrow. But that's what the evidence, you have to at least admit what the evidence is telling us.
Now, he or she says, life clearly shows signs of universal common ancestry. Viruses do not. Do you agree with that?
I agree with the second part. Viruses do not. That's very clear. The idea that life clearly shows signs of common ancestry, universal common ancestry, is a standard talking point. That's textbook orthodoxy. And you'll talk about the universal genetic code and things like that. As we've talked about in an earlier video, these evidences break down, and there are all kinds of problems with the universal common ancestry. One of them, I'll just give one example, is the tRNA amino acyl synthetases, the proteins that are behind the universal genetic code that enact the code, do not fall into a common descent category. So it's actually not true to say that the DNA code is universal like that, because the machinery isn't. This is also true for other fundamental machineries like DNA replication and lipid biosynthesis of the membrane lipids. So some evolutionists, some brave evolutionists, have actually come out with papers and said, maybe life isn't monophyletic. And so maybe there isn't a universal common ancestor to all life. So it isn't true that life clearly shows signs of, I guess you could say clearly shows signs. There's also signs that it isn't, there isn't a universal common ancestor. So there are signs that show both ways, but the universal common ancestry doesn't work the way evolutionists advertise it working. It actually has a lot of problems.
Okay, so Aprender says, doesn't the special creation of viruses, if it was proven, put in a really bad light the creator?
Right. Yeah. So that is a problem that creationists, what creationists will typically do is cast viruses in a positive light, that there are positive uses. Maybe before the fall, viruses did a good thing, and then after the fall, they did a bad thing. So viruses were converted into harm. That's one way creationists have handled that. But creationists will typically want to argue the utility or function of things. They want to show that things have positive function, that they help life. And so that falls under the category of theological utilitarianism. God wouldn't do something that doesn't work quite right or causes harm or something like that. And evolutionists are exactly the same. Of course, they also are theological utilitarians, and so they make arguments like this of like, well, yeah, if God did this, then that's not good. We're going to protect God from that. We have to get God away from this. And so that's the argument from the problem of evil, or from the problem of dysteleology, or the problem of dysutility. Things don't work quite right. Dysutility, they don't work quite right. Dysteleology, they don't look designed. Evil, they cause harm. All those things, we need to separate God from that. That's not biblical, but it is a lot of Christians and evolutionists do that. And that's a driving argument. So this is a very powerful argument, whether you are an evolutionist who is arguing that God needs to be separated from the world, or you are a creationist who is trying to rationalize how could this be. So, but it's not biblical.
And doesn't that kind of go into your answer about why you're not a creationist, because you are not trying to protect God. Like you're not coming up with these solutions. Whatever is what, you're just trying to embrace reality as it is.
Right. And it's fine with me if God did it this way. God could have done it this way. I don't say God didn't do it this way.
Okay, so Laser said, okay, wait, this is sort of along the same lines. So if you have anything more to add, Laser Fan says, viruses, specially created by the magical creator of the universe too, hijack our cells and kill us.
Question mark.
Yes.
The question mark. Viruses, let me read. Viruses, specially created by the magical creator of the universe to hijack our cells and kill us? Are you kidding? Yeah, it's the same thing. God wouldn't have been. This is theological utilitarianism. So this listener has very strong religious feelings. This is a religiously driven person. He will not allow for evolution to be false because of his religion, in spite of the science. And this is so powerful that people don't perceive it. They don't quite understand it. It's like, because it's the deception is so powerful. When you are under the influence of theology to this extent, you don't realize you're under the influence of theology. It's like the fish in the water problem. The fish doesn't know it's in water. So you just think, yeah, this is just so obvious. No question about it. But this is theology. This isn't science. This is in spite of the science. I actually like this comment. I appreciate the comment, because this gets to, if anyone who is in this debate, this origins debate, and discourses with evolutionists, you'll see this sort of thing over and over again. These arguments come up all the time, and they're very powerful, and they are valid. They're perfectly valid argument. But is it a sound argument? Because it relies on a premise about the attributes of God. The attributes of God, certain attributes of God are claimed, and they're burned in to this argument. They are premises of the argument. It utterly hinges on certain assumptions about the attributes of God. I call that religious. Okay, when when you are relying on an attribute of God, I call that religion. I think that's religion. I don't think that's science.
And specifically, you mean like the idea like a good God, all-powerful good God wouldn't do it, right? Like this is not, it doesn't make sense
Wouldn't
for
create
their
viruses.
idea of God.
Wouldn't create, in this case, wouldn't create. Are you kidding? I mean, mosquitoes, viruses, sickness, bacteria that, causing harmful bacteria, the whole thing. Wow, you can't be serious. That's religion.
Okay.
That's religion at work.
Frank
That's why
says
you
good.
have to understand the theology. You have to understand the religion, the history of ideas to understand evolution.
Frank says, good point. Evolution is driven by goofy theology. They hide this by masquerading their mythology as science.
Yeah, thank you, Frank. Yep, that's it. Exactly. It is, you call it goofy theology, but it is very persuasive theology because it seems like it's making sense. It's hard. It's a powerful deception. And when you're confronted with it, it can be very difficult to counter it because it's so powerful. And that just gets to, Isaiah says, our thinking is so distant from God's thinking, just as the heavens are above the earth. We are not thinking like Jesus says, you're not thinking God's thoughts. We are so distant. And so when we're relying on our own thinking like this, oh, well, God would never do that. Oh, really? Okay. You have a hotline to heaven here and you know exactly what God would and wouldn't do. That's very impressive. But that's the problem. We are so convinced, not only are we so distant from God's thinking and we have our own carnal thinking, but we're convinced of it.
Sorry. A question for Dr. Hunter from Dr. Dan. Okay. Have you read the lot on how viruses first evolved? Because it's not a problem for evolution writ large. Just FYI for everyone.
Yeah, thank you, Dan. Good to hear from you. I do disagree with your point. Yes, I have read a lot. I wouldn't be making videos on it if I hadn't read the papers, just like I read the papers for your videos that I made on you when you claimed that bat evolution is obvious and evident in the literature. You said, just Google it, just Google bat evolution, and you'll see, it's very spelled out. And I showed how that is not true. Yes, I have read extensively the virus literature and how they evolved. And you say, because it's not a problem. No, it is a problem for evolution writ large. And apparently you didn't listen to the first part of this video very well, because even at the cartoon level, it doesn't work. So when you say writ large, I'm assuming you're meaning at the scenario level, at the cartoon level. Maybe we don't have a step-by-step explanation of how a virus evolved, but we do at least have a cartoon level explanation. Writ large, I assume that's what you mean. No, that's false. You are making a false claim. So let's get real and let's actually go by the literature and the journal papers. Have you read a lot? Yes, I have read a lot, apparently more than you, because no, it doesn't work. Even at the cartoon level, and evolutionists admit this, they have to, because it's obvious, even at the cartoon level. And so what they are now, some evolutionists are considering, some evolutionists are contemplating, is that, well, gee, maybe different viruses evolved in different ways. We have to take our cartoon level descriptions and apply them. None of them are wrong or right. They just, this virus evolved this way and this virus evolved that way and this one evolved some other way. This is exactly like the evolution of the DNA code. None of the hypotheses worked, so let's just mix and match. It's the cafeteria style mode. Let's pick this one and pick that one when we need it and put them together and separate them out. And so it's a total loss of parsimony. It's a non-parsimonious theory. It's a tautology. Whatever I find, yeah, that evolved. And it just evolved this way. Just so you have ad hoc, just so stories for each virus or each group of viruses. So yes, for everyone involved, everyone listening, this is not a true comment. This is a false comment. It is a problem. And if you think it's not a problem, you're just not familiar with the literature. You're revealing your ignorance of the literature, and you're harming your good name by making comments like this. It's really not reflecting well on you. You need to be careful to protect your good name.
Okay, so B.S. Lewis says, you've convinced me to drop methodological naturalism, Dr. Hunter. Now what?
I'm sorry I convinced you of that, because as I said a couple of times in this video, I'm a methodological naturalist myself. I think you should stick with it, but don't assume that it has completeness and realism. You cannot assume for no reason that all things in the universe, just because I can do work here on Earth, I can do my science with methodological naturalism, and I can successfully do that. That doesn't mean that all of the reality is necessarily naturalistic. So I think you just have to think about what is your particular job, what's your particular science, and how you want to approach it. There's no one right answer. There's no one way to do science, but you have to not smuggle in hidden assumptions and pretend that you have some sort of scientific method that is actually smuggling in metaphysics. Be careful with your metaphysics.
Okay, I don't quite understand this comment, but I thought you might. So this is from Blood Always Finds Its Level. Large or small is already in the gene pool. Who does not know this? Keeping the already existing and working feature is adaptation. We still can't even get an answer. Is this, do you know what's going on with this comment?
No, it's not coherent to me.
Okay, we'll move on.
Yeah.
It might have been part of an earlier comment, so I'm not sure. Okay.
Yeah.
Is it possible, this is from Andrew, that evolutionary biologists haven't given up on evolution yet, then, because they understand something you guys don't?
Well, I when I discourse with evolutionists, I typically I will know more than they do, because they're funneled down into their particular specialty, and they're not aware of the broad landscape of evidence. Is very often the case. And I've read the literature, and there are some evolutionists who are widely read, like Jerry Cohn, and I've read most of what he's written. So no, I don't think they know something special. In fact, I remember hearing that sort of sentiment. It's like, well, if you go and get a Ph.D., if you really get ensconced in this, then you'll become an evolutionist, because then you'll learn that stuff. I remember hearing that sort of sentiment years ago. Well, I did that, and I didn't become an evolutionist. It became all the more obvious. So once you get an understanding of the history and the metaphysics at work, it becomes clear what's going on. So no, I don't think that evolutionists have some, where's the meat? Oh, they didn't say that in biology class, but if you go get your PhD, do your postdoc work, you learn these secrets. There are these secrets, books that aren't published, or evidence that isn't published. But if you just learn enough, you'll learn the secrets. No, there's no there. It's not like there's these secrets that you're going to learn if you just learn more. No, I have a doctorate in biophysics and computational biology, and a lot of work on top of that. There's no unknown unknowns or known unknowns lurking around that we just don't know about.
Well, and as you showed earlier, when you get down and start actually looking at the complexities of life, then, and you see all the details, then it's, becomes even more obvious, right?
Yeah.
That
exactly.
It's not true. Okay. And actually that kind of coincides with what, Dr. Dan says here, some are and some aren't. They are overlapped. At the heart, it's irreducible complexity. So I think he's complaining that we're making the irreducible complexity argument. I'm not sure what he's referring to, but
Right. I would guess that he's complaining that all problems with evolutionary theory boil down to irreducible complexity, and irreducible complexity is not a problem. We've shown that. I'm guessing that's what the comment is, but it's hard to say for sure. None of that holds, of course. Irreducible complexity is a problem. But no, that's not. By far, there are monumental problems with evolutionary theory that do not boil down to irreducible complexity. There are other problems. I like the virus evolution question because it's a little bit contained. Right? Viruses are simpler. They tend to be simpler. Usually they're simpler than cellular life. And so it's kind of a nice little self-contained problem. And you can see so many problems with viruses at different levels. I started out this video with that explanation that there are many levels of these problems. And I did this longer video a couple of weeks ago on this. So no, it's not just merely irreducible complexity, although irreducible complexity is a monumental problem with evolutionary theory.
And B.S. Lewis said, if I believe in microevolution, am I an evolutionist?
Yeah, good question. So I cannot answer that without asking you a question, which is why? Why do you believe in microevolution? Because typically microevolution arguments are religious, are theological, but not always. And so it all depends on, why do you believe that? Because microevolution does fail and fail badly in a lot of instances. So,
whoa, I'm like really surprised to hear you say this. I want to hear what you mean.
Well, yeah, this is a whole nother topic, but adaptation. So this gets into the question of adaptation, because microevolution is usually talking about adaptation. Species adapt, but they don't become different species. So that you see changes within a species. That's usually what we're talking about with microevolution. And adaptation doesn't come often. As we look under the hood and we learn more about adaptation, it's very complicated. It gets to the irreducible complexity problem, and it doesn't arise from random mutations and natural selection. Now,
so you're saying it's like something like epigenetic processes that are causing the organism to adapt to the environment, like an intentional change.
Mm-hmm. Yeah, I call it smart adaptation or directed adaptation. That's not evolution. And when you call that evolution, that's what evolutionists do. They take something that they resisted for decades or centuries, harshly, severely criticized, rejected, ruined people's careers who indulged in it, and then now they can no longer deny it. It's undeniable now, and so now they subsume it, and then they integrate it into their theory and say, "Oh yeah, well that's evolution." No, it's not evolution. It could not have evolved. The preponderance of scientific evidence contraindicates evolution. So epigenetic mechanisms are not likely to have evolved. And so why would you say that this is evolution? This is not evolution. So the whole issue of microevolution, you have to consider the complexity and the fact that the mechanisms involved, if they had somehow random mutations had somehow created, say, an epigenetic mechanism, which would be astonishing, it wouldn't be selected for. Why would it not be selected for? Because epigenetic mechanisms are future looking. They are in anticipation of a future environmental challenge. It's not now, it's in the future. Well, selection is all about now. It has to be now. If it's not fitness improving now, it will degrade and go away. And so the preponderance of the evidence is that these are not they don't fit the evolutionary narrative. And so why would you say that adaptation is evolution? So I don't even like that. I don't think the term microevolution is a good term. But I know what it refers to. A small, I call it small scale adaptation or small scale evolution. So yeah, you just need to think about, so there was a religious doctrine going back to Linnaeus and before Linnaeus called the fixity of species. And that doctrine was that you have a completely static world. It's a creationist doctrine that the world is entirely static. And even Linnaeus, later in his career, dropped this idea because he realizes how foolish this was. So, but you're making it a straw man, two-dimensional cardboard version of the doctrine of creation, that we have this, static world. And so any change that we detect, no matter how it happens, is a falsifier of creationism and therefore a verifier, a proof text for evolution. And that's a religious argument. The key premise of that argument is God would have made a perfectly static world that has no change at all. It sounds silly, and it sounds like something that no one would ever use today in today's world. Not so. Evolutionists, in modern contemporary evolutionists, make this argument a lot, that, oh, well, we just found that this, microbe, added, an amino acid somewhere. So there you go. Evolution is true. It's just pesticide resistance arises. Oh, there you go. Evolution is true. Creation is false. And it's just like, seriously? But this goes back to the fixity of species and the strictly static world. Which is just an absurd model.
Okay, now this question is, or this is getting, when you were talking about Dr. Dan, you were answering his comment and saying his comment about viruses was false. And he said, LOL, this is what my PhD is in, man. Seriously, y'all should know he's lying to you.
What's the lie? I don't get it. Spell out the lie? I didn't. If I lied, I'll be the first. First of all, let me say, I make mistakes as much as anybody, and so when I make a mistake, I will correct it, and so I greet being corrected. And anyone who will correct me, fantastic. Correct me. I appreciate that. Now, the evolution professor that is making these comments, he goes beyond the correction level and he calls me a liar. So he just called me a liar. What that means is I didn't merely make a mistake. I made a claim that I know is false. I knowingly lied. That's a much higher claim. And he didn't exactly, it sounded like what he was saying, that my claim of having a PhD or a particular PhD was a lie.
No, he's saying his PhD is related to viruses.
Oh, I see. So he's got a PhD in virus. Okay, fine. So he's saying that I'm misreading the literature.
So we look forward, Dr. Dan, to seeing you make a video on this, showing how viruses evolved, what we know about virus evolution, and, refuting what we said in this video.
Well, so yeah, so he's got a PhD that's in viruses and maybe virus evolution or viruses or something. It's unfortunate that he would come away with that, saying that what he said earlier in the comment was, there's no problem with the idea that viruses evolved. He made that statement, and I called him out on that. I said, no, that's not reflective of the literature. And so now he's saying, hey, I got a PhD in this, come on. Okay, great. You have a PhD in that. That's wonderful. So you should be able to defend your position. That would be very difficult to defend given the literature. So yes, I am aware of the literature. That's why I made the video. That's part of the video that I made on viruses and my knowledge of viruses. I am up on the virus evolution of virus literature, and so it's full of problems. And so to say that, writ large, there's no problem with virus evolution, and then calling me a liar for saying that it's not so, no, I don't think that's true. I don't think you're on. I think that's off key.
Okay. And I think there's more comments and stuff in the chat, but I'm just going to put up one more because we're almost at 2 hours. We are at 2 hours now. So Andrew says, forgive me if I have some doubt that this guy isn't an intelligent design proponent as he claimed earlier.
So yeah, what he's saying.
Well, I said that about you. I think
Rebekah
I
said
said
that.
you're not an intelligent design proponent. But to be clear, you have done a lot of stuff with intelligent design proponents. So, but I heard you say before that you are not a proponent of intelligent design yourself. So
Right. Yeah, I didn't say that. Yeah, Rebekah said that. So we can drop that concern, Andrew. So when you get into the topic of intelligent design and are you an ID guy, are you not? It really gets into a lot of definitional semantic issues. We'd have to get into the question of what do you say ID is or not, because there's a lot of differing opinions on that. Some ID proponents have very clear definitions of what it is. Evolutionists don't accept that, and they want to call it creationism, a cheap tuxedo version of creationism, or whatever they want to call it. But so you need to get into what do you mean by that. I'm not opposed to the idea that the world was designed. So that strikes me as kind of an obvious conclusion about the world. This all gets, it is a much larger discussion of what do you mean by an intelligent design proponent.
And I think the context in which you were talking about that with me is making a specific claim that relies on comparative theories, right?
Yeah.
And that a lot of the intelligent design arguments rely on comparative theories.
Right. And I believe that there's many different ways to do science and many different ways to evaluate scientific theories, and none are necessarily wrong or right. There's just different ways. I think that I don't want to get carried away with the comparative approach. I think it has its limits. I think it's perfectly fine to evaluate a theory on its own merits. You don't always have to have a comparison going on. And so, yeah, if to the extent that intelligent design is based on this comparison idea, yeah, I'm not crazy about that. So I don't align myself with that. So yeah, there are trends within the intelligent design movement that I do not align myself with. There are also trends that I find to be common sense and perfectly fine. So yeah, it's a little
Okay, so Andrew, basically, Dr. Hunter has not really, hasn't made the strong thing that I was saying, that he's not an intelligent design proponent. So just forget about that. I shouldn't have said that. So in some ways he may be, depending on the definition.
Yeah, that's good. Thank you, Rebekah.
Okay, well, do you have any final thoughts, Dr. Hunter? This has been awesome. I loved the presentation today, so thank you.
I just want to thank you, Rebekah, for having me on. It's been fun, and yeah, hope we were able to tickle some thoughts for the audience, and
yes, and
bring common sense into the discussion.
Yeah, and thank you to the audience for participating, because we always have some really good comments and participation, and that really makes it more fun, because that's what I love to do, is the interaction with people. So yeah, appreciate it.
Yeah, that was fun. I appreciate the people submitting the questions, and some of them were negative and some were positive. That's all good.
Yep. Okay. Thanks, and have a good day.
Thank you. You too.